All right, good day, everyone. Welcome to this exciting YouTube lessons. Um, Today I'm going to be looking at the UTME chemistry. In the exam they are just writing in the UTME currently. Now these questions are questions that they tested on asked them on day one, day two, and day three of the examination. And it has been a normal thing, even over the years, where questions are being repeated. So these guys have question banks, and GTMA, the jamb body has a question bank. They are doing very well. They have a question bank, and they don't exactly repeat the question. They repeat the question. They repeat the question in a similar way, but like a different manner. Similar way, but like a different manner. So that's how they normally repeat their question. So what I will do in this video, I will not just explain the questions. I'm going to explain related. So I'm going to talk about related concepts. So the way this question can be asked, like this first question here now, they ask it in many ways. I'm going to explain all the ways they asked it, and many students have sent me so many questions. I've tried to answer the questions, and so on and so forth. So the first question says, which of the following is an amphoteric oxide? I like to say this. For our level for now, if you're writing down, so first, now amphoteric element is what we call, we use the word bislat for them. So this element I'm going to write here, bislat, and what's it called? They form ferric oxides. So beryllium, zinc, lat, lead, okay? Be, so the shortcut is Be Z A Z L A T. BeZLAT, that's bismuth, beryllium, zinc, lead, aluminium, tin. Amphoteric oxide. So amphoteric oxide here is, what's it called now? Lead oxide. And let me quickly talk about oxide, the musical test all questions on oxide again. Now, quickly, the UTME examination body can ask you which of the following is an acidic oxide. Acidic oxide are usually oxides of known metals. They turn blue litmus paper red. Do you get? While amphoteric oxide are oxide that can act as both acid and base. Do you get? So another question came in the examination. They asked us which of these oxide is a basic oxide or dissolve. Which of these oxides dissolve in water to produce a base? That's a basic oxide. Basic oxides include oxides of group 1 and group 2 elements. So group 1 and group 2 elements such as sodium, let me just write it here, such as Na, such as K, such as Ca, such as Ba. So the only group 2 element that is amphoteric is beryllium. Beryllium is in group 2 but is amphoteric. So group 1 and group 2 elements, their oxides are usually basic. They dissolve water and their solution turn blue, red litmus paper or red litmus to blue. Did you get this one? That's for basic oxide. While neutral oxide includes CO, include water, H2O, include NO, include N2O. The only oxide of nitrogen that is acidic is NO2. So acidic oxide, CO2, NO2, phosphorus oxide, chlorine oxide, they are all acidic oxide. This should not be forgotten. You should not forget this. Acidic oxide are the one we call acid anhydride. Oxide. So the guy writing on, if you're writing on Monday, you're writing on Tuesday, or probably Wednesday. Please take note. Acidic oxide is what we refer to as acid anhydride. They include the highest oxidation states of the oxides of non-metal. They are the highest oxidation state. So we don't say carbon 2. The highest oxidation state of carbon is carbon 4. So carbon 4 oxide is the acidic oxide. Nitrogen 4 oxide is one of the highest, one of the highest. It's an acidic oxide also. So that's NO2, acidic oxide. Phosphorus oxide is acidic. In solution, they turn blue litmus to red. Okay. So please note that this question two came out I think on I think day two or day three. Now, which of the following decomposes on heating? Now, please take note. They asked this question on triazocarbonate salt. I've said it before. Now, triazocarbonate salt, any salt that have CO3, any metallic triazocarbonate salts are all what's it called? They are not all stable to heat. Do you get? Only two triazocarbonate salts are stable to heat, which is that of potassium and that of sodium. So for our level, only triazocarbonate salt of potassium and sodium are stable on heating. Every other triazocarbonate salt decompose on heating. So this one will decompose on it because it's not that of sodium, it's not that of potassium. And calcium oxide is a compound that is very stable to it. Calcium oxide is called quicklime, it's very stable to it. It is used to dry ammonia in the laboratory. Calcium oxide is to dry ammonia in the laboratory. Now, drying ammonia brings you to something. So the answer to this question is B. So drying ammonia brings you to something. Now, they tested this question on HCl. If you are writing this examination on HCl, so they tested these questions on HCl. Now, what did they ask on HCl? They asked him, the UTME body is asking them on HCl. How do you test for HCl? There are two ways to test for HCl. Now, you use a jar of ammonia or use silver nitrate. Two ways to test for HCl. So HCl is as a hydrogen chloride, as a gas, can turn blue litmus red. HCl and even ammonia is used to demonstrate the Fountain experiment. The Fountain experiment tells how soluble a gas is. So the Fountain experiment describes the solubility of a gas. All these were tested during the exam. I think day 3 yesterday they asked HCl is used to describe the Fountain experiment due to solubility of the gas or the solubility of the gas in water. Now they can change the question. How do you change the question? Now they can bring this question out like this. They'll not say HCl, they have, for instance, HCl, what's it called? It is very soluble in water. Normally, the solubility of every gas, these are the can ask now. Normally, the solubility of every gas, what's it called, increases with a decrease in temperature. So the lower the temperature, the more soluble a gas. But for HCl, it is the reverse. HCl is the only exception for gases. So for HCl, the higher the temperature, the more soluble the gas for HCl. Do you get? So these questions can be tested like that. You can test. Now, two ways to test for HCl, hydrogen chloride. Hydrogen chloride, the fumes, hydrogen chloride. Now, hydrogen chloride forms a white dense film of ammonium chloride when placed in a jar of ammonia. So when you place hydrogen chloride in a jar of ammonia, it forms a white dense film. Do you get? Now, another way to test for hydrogen chloride is using silver nitrate. So HCl produce a white precipitate with silver. Tested this question yesterday. Which of the following is used to test for? So many options. This one was there. HCl produce a white dense film with silver nitrate. It also asks for the extraction of sulfur. The extraction of sulfur is via the Frasch process. So all these questions can be tested. They can be tested, and I want you to look at them quickly. Pause the video, go back to the video. At this point in time, if you have not liked this video, you are wrong. You're doing the wrong thing. So I urge you to like the video and be helpful, like it. Now, they have this question again. Rust on a metal surface contains. Now, please, I've said that rust is brown hydrated iron 3 oxide. So rusting is the corrosion of iron. So rusting or corrosion occur in the presence of oxygen and water vapor. You don't corrode that. You don't rust or corrode. A metal does not corrode or iron does not rust without oxygen and water vapor. There must be oxygen and water vapor. So brown hydrated iron 3 oxide is rust. Do you get? So that would be option C. Now you can ask a question on what kind of question can they ask on the before? Now, how do you prevent rust? To prevent rust, you can coat with zinc, which is called galvanizing. So if you want to prevent rust, ways to prevent rust are coating with zinc, which is called galvanizing. So galvanizing is called the coating plating. So I can plate with tin. I can do greasing, and so I can grease. I can do oil painting. And that brings me to something. I think they ask this question. The solvent for paint, the most common solvent for paint is turpentine. Turpentine is used to make oil paint. This question was tested. So solvent for paint is turpentine. Turpentine is used to make oil paint. So you have seen those oil paints used to paint surfaces. Many of them are made from turpentine. So this question was tested. Another way to prevent rusting again. These are ways to prevent rusting. Sacrificial cathodic protection. Don't forget that. So I call this we normally use magnesium. Sacrificial cathodic protection. So one way to prevent rusting. The lithium as the cathode. So that's another way to prevent rusting. Please, um, I'm preparing a video. You all get it today. You all get it today or tomorrow. Now the video is all I should know in organic chemistry. So please, if you're writing the UTM and watching this video, I tell you please go fall back to your organic chemistry videos. I have videos on this channel on organic chemistry. Look at them. It's analyzed everything what they can possibly ask. So this question number 4 is on organic chemistry. Which organic compound can undergo geometric isomerism? Geometric isomerism is common to alkenes, compounds with double bond. Geometric isomerism is common to alkenes, compounds with double bond. So how do you need a compound with double bond? So alkenes, they actually have the formula of CnH2n. So who follows there? That should be 1, 2. Okay, I think this. So C4H2. So 2N, 2 times 4 is 8. So this is butene. Butene can exhibit geometric isomerism. So if I should draw butene for you, something like this. This is butene. So this is 8. So, so now if you check, now why is he exhibiting geometric isomerism? Geometric isomerism is what you refer to as cis and trans. So this is cis. So why does cis and trans isomer occur? Now because of the restriction of the free rotation about a double bond. Due to the restriction of the free rotation about a double bond. What do we mean? No long talk. Now this cannot come here. Compound, this H cannot go and replace this H. They cannot interchange. Why? Because double bond in that free rotation. So when we write a new compound, when we write another compound where the CH3 is now up, another one is down, it's different from this one. So this one is called a trans isomer. That one is called a cis isomer. This is geometric isomerism, common to alkenes or compounds with double bond. So I'm going to leave a bonus at the end of this video. The bonus will be on metals. I'm going to say every possible thing that Jam can ask you on metals. I'm just scared for Monday set. Every possible thing that Jam can ask you. Okay, now the next one is on electrolysis. Okay, this one is on electrolysis. Um, it's lovely. This question is lovely, very very lovely. Now, the question says, what quantity of electricity will liberate 212 grams of silver molar mass? So 212 grams of silver without molar mass. So I've always, if you followed me right from time, I've said this. Now, to calculate most questions, 90% of the questions on JAM and electrolysis is Q equals to FEN. It does the work. Now, what's Q? Q is IT. So always the question is looking for Q, quantity of electricity, current times time. Now, Faraday constant is 96500. They normally give this in the question, but as a student, you're supposed to know it. 500 coulomb per mole. So F times the charge, silver metal, the charge on silver is usually +1. So you're supposed to say, but usually +1, that's on silver. The M, M is mass over molar mass. So our mass over molar mass. So molar mass is 106, our mass is 202. So quickly, I might not even need a calculator to, you can just do it when you're on your spare time. So how do you solve this question? F is 96500. So to solve this kind of question, I would say 96500 charge on silver, which is 1. What's the mass of silver? There, 212 grams. That's mass all over 106. I therefore have options. So the person that sent me this question did not give me option. So this is how you calculate for Q. If you are wondering, where do I get F from? 96500. It's Faraday constant. It's constant. Charge on silver. Check your electrolysis topic. Your textbook. The charge on silver usually +1. Okay. It can be silver. They can be silver 2. You get what? Most times, it's silver. Most silver salts are usually 1. Then 212. Then AgNO3. So you get. So this is it. So now, lastly, soft soda is an alloy of soft soda alloy of. So soft soda is an alloy of which element? Subsoda is an alloy of Subsoda is an alloy of lead and tin. Let me give you possible alloys. Subsoda is used for plumbing. Alloy of lead and tin. Lead and tin. And lead is a metal that is very dense. So that's why lead is used to make bullets, one of the most dense metals. Okay. Thank God. Now, lead. Now, what was lead used for? Lead is used to, what's it called? Lead is used to make bullets also. And lead, the main ore of lead is galena. How do you extract lead from galena? If you're writing these days, just take note of this. How do you extract lead from galena is by reduction, chemical reduction using coke in a laboratory furnace. Chemical reduction using coke in a laboratory furnace. And the main ore of tin is cassiterite. They ask this question: how do you extract tin from cassiterite? By chemical reduction, also using coke. So pardon me, lead is in the blast furnace, while tin is in the laboratory furnace. So they ask this question because of that. Cassiterite, C-A, okay, can I write it here? So CASSIT. Yeah, this is cassiterite, the main ore of tin. Galena, the main ore or the principal mineral of lead. Yes, another alloy that the UTM body loves very well is duralumin. Duralumin is used to make aeroplane parts because it contains aluminium, which is light and resistant to corrosion. So duralumin is an alloy that is resistant to corrosion. It's an alloy of aluminium, magnesium. So an alloy of magnesium is duralumin. The manganese, the copper. Duralumin is light and resistant to corrosion. So that's why it's used to make parts. Also, aluminium metal is very light and cheap. Also, aluminium metal is very light and cheap. That's why it's used to make overhead cables. For That's duralumin. Aluminum metal is resistant to corrosion. You should take note of that. And we transport HNO3 in aluminium container. We transport HNO3 in aluminium container. Another alloy used to make magnets is permalloy. Permalloy. Permalloy is an alloy of iron and nickel. Nickel being the base metal, that is nickel is more. Nickel is around about 60 to 70% in alloy, while iron is the remaining part. The alloy. Another alloy you can be asked, and please take note, for iron, the main ore of iron is hematite. The main or principal mineral of iron is hematite. Hematite. So this is hematite. In case you are, I think they can also ask the formula for hematite. Fe2O3. This is hematite. This is where you get iron from. Iron is extracted from the blast furnace. The main reducing agent in the blast furnace is coke. The earthy impurity in the blast furnace is removed. The earthy impurity in the blast furnace is removed using what's it called? The earthy impurity in the blast furnace is removed using limestone. The earthy impurity is removed as slag. The earthy impurity in the blast furnace is removed as slag. Slag is a compound. So write it here. Compound. So slag is a compound called CaSiO3. So this is slag, everybody. This is slag. So limestone is used to remove the earthy or the silica impurity in the blast furnace slag. Other ore of iron is other ores of iron I feel they can test is magnetite. Magnetite is lodestone. Okay. Magnetite is a magnetic ore of iron Fe3O4. That one of iron is full iron pyrite, K, and so on and so forth. So as I said before, aluminium. When you talk about aluminium, the main ore of aluminium is bauxite. Bauxite has two forms. Another mineral of aluminium, so there is another form of bauxite, corrodium. So corrodium is different from bauxite. The one difference is that bauxite is I think bauxite is Al2O3, 2H2O. Corrodium is Al2O3. Do you get? So this is the difference between bauxite and corrodium. Bauxite and corrodium, they are both aluminium oxide. So they can also ask you, aluminium oxide exists naturally, it can be bauxite, can be corrodium, depending on what's in the option. So they can ask you, aluminum is basically mainly extracted from bauxite. Some people use corrosion. But bauxite, what do you do to bauxite? You first purify. You purify by sodium, you purify using sodium hydroxide. You purify using sodium hydroxide and you dry to get alumina, which is pure aluminum oxide. The electrolysis. So it means that aluminum is a metal that can be extracted by electrolysis of its oxide, while calcium and sodium, they are extracted by the electrolysis of their chloride. Please don't forget that aluminum is extracted from the electrolysis of its oxide ore, which is first purified using sodium hydroxide to get purified alumina. But calcium and sodium are extracted by um, the electrolysis of their chlorides. If you know your electrochemical series very well, by now you should be aware that in your electrochemical series, let me just drop something here. Elements below aluminium are extracted by reduction. Elements below aluminium are extracted by reduction. By now in your electrochemical series, you should be aware of that. So what I mean is simple. What I mean is if I have K, I have Na, I have Ca, I have Mg, I have A, I have Zn, I have Fe, what's it called? So Al, I have Fe, I have for metals, okay, let's use Sn, Pb, Pu, Hg, and so on and so forth. So elements below aluminium are usually extracted by reduction. Please don't forget chemical or thermal reduction. Why these elements here above are usually gotten by electrolysis. So it's from electrolysis of the chloride. Magnesium is always also electrolysis of the chloride, but aluminium is gotten from the what's it called, the electrolysis of its oxide. Don't forget, the UTM body can ask you all these things to make the video not too long. Okay. So I'll do another video on this. So please keep it posted, subscribe if this has been helpful, this channel has been helpful. If helpful in coming years. If you're a science student, you are going to do biochemistry, you're going to do chemistry. There are more contents and videos waiting for you. But next video, it's bye. Share this video with your friends. Don't be stingy. God bless you.